This section is called section 1.5, and is order of operations. And so the first thing I want you to do without talking to your neighbor or anything else, I want you to solve this problem right here. 2 plus 3 times 5 plus 1. I have it written twice because there's 2 ways to do it, only one of which is right. So I just want you to work out that problem. As I walk around, I only see 2 answers. All right, I only see 2 answers. I see 18, and I see 26. Those are the only 2 I see. Goodbye, my dear. Have fun at soccer. I canceled your doctor's appointment, so you're just I canceled it, so you don't have to go to it. You'll go soccer all the time. Okay? All right. I think he thought I told him he was having to go to his doctor's appointment, but I told him this morning he was supposed to have one, and he said not happening because they're supposed to have their first game tomorrow, so he feels like he needs to be at soccer practice, and it is just an ear recheck, so I canceled it. So, because he had an ear infection a while back, so I won't go to the doctor and get sick. Everybody at the doctor is sick. So, all right, so those of you who got 18, I think this is what you did. 2 plus you did 3 times 5, which is 15. And then 2 plus 15 is going to give you 17. 17 plus 1 is 18. Those of you who got 26, this is what I think you guys did. 2 plus 3 is 5. 5 times 5 is 25. 25 plus 1 is 26. So, would you guys agree that, like, in my arithmetic, only one of these is right, so I've made an error on one of them. But just in my arithmetic, I've not made any errors, right? And what I was telling you that I did, it wasn't like I said 2 plus 3 is 7, right? I've not made any errors there. So, like, if you didn't know anything about order of operations, as maybe some of us don't or have forgotten, these both seem like logical ways to get to an answer. But which one is correct? What do you think, Ian?
26.
You think 26? What do you think, Lanaya? Think 18? Okay. Ian, why do you think 26?
Because if you do order of operations, you would do 2 plus 3 is 5, and then you would do 5 times 5
Okay? Lanaya, why do you think 18?
Because you have to do multiplication before.
Okay. So, Lanaya is the one that is correct. 18 is correct here. So, order of operations, there are certain operations we have to do before others. This way, you're doing everything basically in like a left to right order. But order of operations tells us that we're not going to do everything necessarily in a left to right order. So, so this one here, unfortunately, from a 26 crowd, is incorrect. About half of you had 26, so if you got 26, don't feel bad. But 26 is not correct. And order of operations is really important because if we don't have order of operations established for mathematics, then so many problems can have 2 or 3 or different answers, right? And that is an issue because we need to have just one answer for these different things. So, order of operations, let's refresh our memories of what it is. Can I do it this way so it just shows what I want to show right now? Yeah. So, oh yeah. Okay. So, you guys hopefully have seen PEMDAS before, or please excuse my dear Aunt Sally. So, in PEMDAS, what does the P stand for? Parentheses.
Do we write that down?
Yes, I would. So parentheses is the first, and this is, I'm going to put over here in the, beside it, grouping. I think somebody was telling me that PEMDAS is now GEMDAS, because some teachers want to use the phrase grouping instead of parentheses, because up here we did have parentheses in the problem. But was it really what parentheses is talking about here? It was not, because there was only a single number. These parentheses are just used for multiplication. So some teachers use the term grouping here because that would be like if you have more than one thing inside of parentheses, you need to do that first. So I am old school though, so we're just going to stick with the P here. E, what does E stand for? Exponents. Okay, M, multiplication. D, division. A, addition. And S, subtraction. Okay, so I'll leave that up there. Make sure you've got this down. And I have a box drawn around multiplication and division, and another box around addition and subtraction. Okay? The reason that I have those boxes there is because multiplication and division, really, if we wanted to, we could switch that order there. They are not real. Multiplication doesn't have to come before division. They're equals, right? So, whenever we get to multiplication and division, we go left to right. So, if we were left with something where we have 20 divided by 2 times 7, we do the division first, then the multiplication. So, division can come before multiplication if you get down to just having those two. Same thing for addition and subtraction. We go left to right. But we must make sure that all multiplication and division is done before we go down to the next step where we add or subtract, right? So if we go back up here, let me make sure everybody's had time to get that down, actually. right, so if we go back up here to the problem that we started with, there are no parentheses, not grouping parentheses anyway, right? There are no exponents, so that means multiplication or division must be done first. We do have multiplication, so we have to do that first. We have to do 3 times 5, which gives us 15. Then we're down to everything being addition, so we just go left to right. 2 plus 15 is 17. 17 plus 1 is 18. So 18 is your correct answer here. The reason we cannot do it this way is because if we do 2 plus 3 first, we have added before we multiplied. And order of operations says that we can never add before we multiply unless it's in parentheses and been grouped together. All right. So let's try this example. I'll give you a second to write it down and then try that one. All right, so we got 2 times 3 plus 1 minus 5. So, Cam, I'm going to get you to help me on this one. What will we do first? Very good. So, we get 2 times 4 minus 5. What comes next? Good. So, we'll get 8 there. And now we're down to one step. What's our answer going to be for this one? 3. Very good. Okay, questions on that one? All right, here's your next one. Write this one down for me. Now, this one looks like it has a fraction in it. But our fractions are also division, right? So whenever we see something written as a fraction, if we see 1/2, that means 1 divided by 2, right? So when we see something written as a fraction, we're going to treat that as division, a division symbol there, okay? So, Evan, what would I do first for this one? Okay, so I've got 6 whenever I do that. I will say this, though. If something is written as a fraction rather than written with a division sign, it is like you've got parentheses around that fraction. Okay, so like, for example, here, I said for multiplication and division, we would want to go left to right. But you would not multiply before you divide here. You go ahead and do the fraction first. They're sort of like invisible parentheses there. So, Evan, next. It's 18. Yeah. So what do we get when we do 18 divided by 3? 6. Okay. Keep going for me here. And finally, what's our answer? Very good. Okay, questions? All right, let's try a few more. I'll go ahead and let you write 3 and 4 down here. let's see. Lexi, help me with that first one there, example 3. What should I do first? No. Not 4 times 8. This one's specifically here to mess you up. Now, you're saying, Miss Hyatt, over here, in PEMDAS, M comes before D, right? Plus it just looks like it's easier to do it that way. But, multiplication and division are equals. So multiplication and division, we go left to right there. So since this problem only has multiplication and division, we are actually going to go left to right here. So we got to do 24 divided by 4 first. It seems backwards, but it is what you're supposed to do. So 24 divided by 4 gives us 6. And then we bring down our 8. And 6 times 8 is going to give us 48 there. So we'll get 48 for our answer. Example 4 is the same because we've got addition and subtraction, but we do not do addition before subtraction whenever we're down to just that. Right? So since this is only addition and subtraction, we're just going to go left to right. So 8 minus 5 is going to give us 3 plus 2 minus 15. 5 plus 2 will give us 5 minus 15, and we'll get negative 10 for our answer. So be really careful with those, because it just, to me, it even looks wrong to do it this way, but it is not. This is the correct way to do that problem. Okay, questions on those? All right, here's a couple more. Write these down for me. Okay, so for example 5, we have like a giant fraction, right? We've got a fraction, and we got stuff in the top and stuff in the bottom. So when we see something like this, they're not written there, but we have invisible parentheses around the numerator and invisible parentheses around the denominator. So you would want to do whatever is in the numerator and in the denominator before you try to divide there. So, and it's okay if you want to go ahead and do both at the same time here. So if I do 28 minus 3, I'm going to get 25 in my numerator. 2 plus 8 in the denominator is going to give me 10. And then I want to divide here, but will these divide evenly? They will not. So what should I do instead? I can just reduce it, and what do I get whenever I reduce this one? 5 over 2. What's that as a decimal in case I want to give a decimal answer? 2.5 there. improper fraction is fine, but it is 2.5. Okay, let's look at number 6. Giancarlo, on number 6, what should we do first? Good. So we've got those parentheses. They need to be done first. What will I get when I add those together? Very good. Okay. What's going to come next, Giancarlo? Good. What's that going to give us? Almost. So we'll multiply 4 times 7, which gives us 28. So when we multiply decimals, we ignore the decimal at first. How many decimal places do I have? I just have 1, right? Because 4 doesn't have 1 at all. 7.7 just has 1 decimal place here. So instead of 0.28, we'll have 2.8 there. And then the last step is to subtract here. What will I get, Giancarlo, when I do 2.8 minus 3.8? -1. Very good. Yes, that's fine. If you do -1.0, that'll be fine too. Okay, questions there? All right, I got a couple more I want us to do. Here, actually, got 3 more. Let me accidentally, hold on. Let me fix that real quick. We'll go right back. Okay. I'll let you write these 2 down and then we'll do these. We're starting to get complicated. At this point on problems, you should not be doing the whole thing in your head. I can probably do it in my head, but I probably wouldn't. I'd at least write down a couple numbers if I did it. So you guys on these bigger ones, please show a little bit of work at least. Because if you don't, I'm going to suspect that you, for your homework, just went shh and wrote down the answer. Shh and wrote down the answer. I'm well aware Photomath will do these really quickly. It works great. I use it all the time. I Photomath answer keys sometimes so that I don't have to do it all. It's an app on your phone. Yeah, there are some things it cannot do well, but order of operations it can do pretty well. And what I don't usually use it in this class very much. What I use it for is sometimes in like pre-cal, we have really long equations. So I might either use it to check my work to make sure I didn't make a mistake, or I will use it to like do a problem that I haven't worked out myself just to see what I get to do for the answer key, so that just so I can be faster about it, because I already know how to solve the problems really well. So it does work. In fact, if you want to work out every single one of your problems by hand, really thinking about it, and then go back and Photomath them all to see if you got them right, I don't mind that. What I don't want to see is you just writing down the answer, writing down the answer, not thinking about it at all. So if you're using it to check your work, it can actually be a good tool. But I find that sometimes children do not use it to check their work. They just copy it down. All right, let's look at example 7. So let's see, Savannah, what would we do first on this one? Parentheses, very good. So we got to do 4 plus 2, which is going to give us 6. Very good. What comes next, Savannah? Exponents. And what is 6 squared? 36. Very good. And it really doesn't matter here because you'd go left to right anyway. So you would divide first anyway. But remember, if you have something written as a fraction, it's like it's got a set of parentheses around that as well. So what comes next here, Savannah? Good. And what's that give us? 3. What's after that, Savannah? Very good. So that'll give us negative 40. If you want to write that as 3 minus 40, that would also be okay. And then what's our final answer going to be for this one, Savannah? Negative 37. Very good. Okay. Questions? Oh no, why would she do this to us? Order of operations with fractions. Oh. Yeah. I like that you're saying that, and I agree, but usually there's not too many people that also feel that way. So, Anna Grace, what would we do first on number 8? Good. And so what will we get when we do that? Very good. Don't have to worry about common denominators there because we're multiplying. So we just multiply straight across. So 1 times 3 is 3. 2 times 4 is 8. Okay, what comes next, Anna Grace? Good. What will we get whenever we do that? 6/8. And there we already had common denominators, so we didn't have to worry about denominators on that one. All right, last step. Obviously, we just need to subtract these. If you want, you can reduce 6/8 and make it 3/4, or you can just work with it like this and reduce at the end. It really doesn't matter there. So let's just leave it like it is. But what have we got to do before we can subtract those, Anna Grace? Good. And what should we multiply by so that we can get common denominators there? 4. So we need to multiply this second equation here by 4. So that gives me 6/8 minus 4/8, which will give me 2/8. And what does that reduce to, Anna Grace? Let me give you a second. One-fourth. Perfect. Okay, so you got to combine those rules you know for fractions and think about order of operations as well. I got one more I want us to do, and then we're going to do our assignment. And on this one, I used brackets instead of parentheses. We'll see these on a lot of problems because often we'll see that there's like a parentheses right here, and they just want to sort of like differentiate here so that you see the brackets and the parentheses so it doesn't all run together. But brackets act the same as parentheses. They're just a different grouping symbol that we can use. So, let's see. Let's get Rosalind to help me on this one. What would we do first on this one, Rosalind? Okay, and what are we going to do first in those parentheses? We're going to multiply, right? Because we actually have two things to do inside of those parentheses. So we're going to multiply first. So that'll give me 1/4. 2 plus 20. What do I do next, Rosalind? Okay, so we'll add those together, the 2 and the 20, because they're inside of those brackets that mean grouping, right? So 1/4 times 22. minus 2 to the third power. Okay? What's next, Rosalind? You could get by with doing it as long as you don't do something else first. But what technically comes first next according to order of operations? Exponents, right? So I'm going to go ahead and do 2 to the third power. What is 2 to the third? 8. It is 8. 2 times 2 times 2, right? So I'll have 1/4 times 22 minus 8. Now, because those are separated by subtraction and we know the next step is going to be to multiply, if you did that step at the same time as you multiplied by 1/4 times 22, that would be okay. So we're going to put this 22 over 1 and multiply. So that'll give me 22 over 4 minus 8. And then I can either reduce, does 22 go into 4 go into 22 evenly? If you want. Yes. It doesn't go evenly, so you can either reduce now or you can reduce at the end. So either way, it really doesn't matter. It might be easier to reduce right now. Let's make that 11 over 2 minus 8 over 1. Rosalind, what will we use for a common denominator there? So we'll multiply by 2 right here. So we got 11 over 2 minus 16 over 2. And what will we get for our answer, Rosalind? Perfect. -5 over 2. Or, if you want a decimal, -2.5 is okay also. For the most part, I don't care whether you're using decimals or fractions as long as they are correct. But I will say, sometimes questions like these are going to be multiple choice, and it may only have the fraction answer. So you have to know how to do it both ways there. But if it's like a worksheet, I don't really care which one you do, but just don't use a calculator. Alright, so our assignment, we're going to go ahead and get started on right now. This assignment is going to be homework if you do not finish it. The other one that you guys have where we do fractions, that one is not homework. You do not have to finish it. So we're going to work on this until the end of class.